Welcome back, part 25. This is going to be another fun one. Motion detection. So, what is this about? The goal is to be able to dynamically pan, i.e. move left and right, up and down, and zoom on the short screen captures. So, if we look at the shorts at the moment, you can see the format. Me on the bottom, that's fine. Let's play.
Be a fun thing to.
Oh, let me mute it. And in fact, let me open the captioned one because it looks way better captioned. So this is how the shorts look. So you got caption in the middle, me at the bottom, whatever the screen recording is at the top. Now, when that's edited, I've got the full screen recording. So the bit that's the sides that's cropped and that on the left and right, it's squeezed in top and bottom. All of that's available. So my goal is to be able to move the video around and focus in on what is moving on screen. That's the goal. Whether this is possible and whether this can, generate decent results, we'll see. But that's the goal. How? So I'm going to add a new processing pipeline step to extract motion information out of the video. There's various ways to do it. So there's one I've picked, I'll talk about in a second, that's going to be the first one I try. It may work, it may not, and depending on how well it works, that may inform whether I just drop this whole idea or whether I try one of the other motion extraction technologies that are available. Whatever it extracts, because I'm imagining it's going to be per frame data or close to it, will need some kind of smoothing algorithm. i.e., if it's going this move, this move, this move, this move, that's not information that I can apply into a pan here, zoom here, because it'd be crazy. It would just wreck the screen recording. So it's almost two things. It's a smoothing algorithm and it's a, I guess, editorial decision algorithm to go, okay, let's pan no more than once every 5 seconds, or let's zoom no more than once every 5 seconds. So if this thing is sort of saying, you've moved here, and you just let it apply, you want to go, whoa, hold on, just don't do it too much. There's going to be all sorts of problems like boundary conditions, like having caps on, if it's just detecting a small bit of motion in the screen recording, what are we zooming in on? Am I zooming into the cursor? No. So there'll be things like minimum or maximum zoom levels, like say 40%. Same for the panning. I'm only going to apply this to shorts. I'm not going to apply it to the main video. I think it would drive everyone crazy if you watched a long video like this and saw this at play. But who knows? If it works on shorts, maybe we come back and see if it would work on the bigger videos. The other reason I don't think it would work on the bigger videos is because sometimes I'm not doing anything like right now, and I might be talking about something on screen. And if I just let loose and decide where it wants to zoom and pan and edit, it could just be hiding something that's relevant context visually. So I don't think this will ever apply to main videos. For the shorts, it doesn't matter because there's not going to be too much in the shorts that anyone's going to be paying attention to. The shorts are an advert for the channel. The shorts are not intended to be, you're going to learn too much from them. They're really what is this guy up to? I'm going to follow him kind of vibe. Not the best short strategy in the world, but it's a free one now. For Pray, this works because I'm not confident on this one. FAQ. Why not the main video? I've just covered that. Tech. So we got 5 options. This was a Claude chat. I have actually referenced in this series a few times now because I just asked Claude how to do this. And there are 4 texts in FFmpeg. that spit out different things. Freeze detect will do frozen segments, not too interesting. Scene change detection, for what I'm doing, I don't think this is too interesting because I'm kind of just in front of VS Code all the time. I can totally imagine how this would be useful on camera footage. M estima MP decimate, motion estimation filters. This sort of sounded promising to me. And then FFmpeg signal stats, outputs per frame stats, including difference from previous frame. Claude thinks this one will be the best for the pipeline, but then it then said you really want to go with Python and OpenCV. I don't know what OpenCV is. I've never used it. This is the one we'll be going to. So my plan is to test this on this video we've just been looking at, because it's got lots of movements, especially on the screen recording. That's the one I picked it, and it's a short one. So the shorter videos are just easier for the pipeline to process. So that is the plan. Close that. I've written a PRD. It's pretty short. It's only a PRD for the first script. So I'm not going to go build the whole thing, because really the goal for this is just to see the data it extracts. So depending on what this does, I'll then make a call on, okay, where do we go from here? And it will be either, okay, this is complete junk, or we start looking at it in terms of an algorithm to process the data. So very simple PRD, build a new pipeline script down here to extract the motion information from the video being processed. Create the script after script 01. Name it that. So I'll do 1A. If I use this later, I'll sort the numbering out. That will use Python and OpenCV to extract motion information from the video. Write this motion information to a file. That's all I want this to do. So we'll run it, it'll dump out, and then I'm just going to look at the data. And then we'll try and figure out from the data if it's usable. Otherwise, I will probably come back and prompt Claude and go, hey, can you make this readable for my dumb human eyes? This code is the code from Claude, the Claude code chat. So I've just pasted that in example code. Another reason I want to just do this bit in isolation is I've no idea how long this is going to take. I don't know how performant this CV2 thing is. I can imagine this won't be quick. I can imagine this could be quite an intensive process. It's going through every frame and it's doing something to figure out colors. As I'm saying this, I'm reading the code. This is interesting. So it's doing it based on color. Find contours of moving regions. So this is what we're going to get out. Motion at X, Y, W, and H. Okay, let's see how we go. I'm on a new branch. This is only the second time I've created a branch to specifically work on a feature. Yeah, let's see. Okay, analyze this requirement. I mean, it's pretty straightforward. I'm going to do it plan mode. I could just go build, but let's see what Claude thinks before it codes anything. So as I say, only the second time I've created a branch. So what will happen is this is going to go in stages. So if this bit works, then we'll move to this sort of smoothing algorithm I'm talking about, and then we'll move to applying it. The applying it stage could be just as bad. i.e., we could get past the numbers being a problem, and then I could be applying it and find the zooming and panning within FFmpeg looks crap. So there's multiple points of failure in this, hence why I'm going to run it on this branch. I can now switch back to main and work on bugs and other things, and come back to this. And if I abandon it, I can keep the branch, which is the other benefit, because I can just push the branch up to GitHub, and then in a month's time when I go, I'm going to try and get that working again, I can pull this branch out and see where we left off. But yeah, this is an interesting one. Another thing I might do, if this is successful, is have a go at motion blur. So that was another thing. End of this Claude chat. Can FFmpeg apply motion blur effect? Yes. There's a couple of ways to do motion blur. T-mix filter, minterpolate T-blend. Cool. So every time it does a pan, every time it does a zoom, we do a motion blur, which would totally cook the FFmpeg processing, but it's only going to be on the shorts, so it'd be quick. All right, what have we got, Claude? Add a new pipeline step. Step numbering, non-trivial. Okay, so it's going my 1A hack, ain't going to work. Okay, OpenCV not dependencies, cool. Workspace directory, no. Motion, cool. Easy stuff. Output data format. Example code just prints bounding boxes. A proper output file should include per frame events with timestamps and a summary. Cool. Yeah. One question. Should motion detection run on every frame, accurate but slow on long videos, or sample every n frames per speed? If sampling, what default would you prefer? Every frame, most accurate. Every fifth frame. Okay. Configurable. I'll do configurable for that. So this already solves part of the problem. So where I was just saying, it'll be too much information, doing a sample is definitely a good idea. And then what I would probably do is do averages. So if we land at, say, I could imagine doing this like once a second, maybe twice a second. So really not do it very much. And then you'd want to average over multiple seconds. So say every 3 seconds, get the vector out of this is where the motion is. Maybe. We'll come back to that. Okay. What's it want to do? Script numbering, input source, output source, faster modify, logic, yada. Yeah. Right. No, keep planning. Don't change the script number ordering. Let's make this and increment the remaining scripts. So what it was saying above about that's going to cause problems doing that 1A, and then it's going, oh, I'm going to do all this crazy processing. That 1A was just me trying to be hacky, but no need to do that. It'll nail that. So I'll give it that feedback. It did this once before. I did a thing where I injected a script in it, and it correctly reordered the remaining. Got it cleaner and simpler. All existing scripts from 2 onwards get their prefix incremented by 1. Cool. From that video as well, it didn't correctly rename all the references to these scripts across the code, so that will be a to-do for later. Again, because I'm on this branch, I'm not going to worry about it too much. This is very much a spike. Pip install, run that. Oh, okay, yeah. Go. Okay, I'm going to pause while this runs. We'll come back when it's finished. Okay, it's finished. Little dependency, OpenCV to install. I've just done that. And we have a fresh new script to run. Let's take a quick look at the code. I don't think it's going to be much to it. Okay, I'm wrong. Bit more code than what was in that sample, but given all this stuff about the sampling, I'm not surprised this is higher. Right off the gate, I'm going to change that sampling. So we go to config. It should have added this. Yes, it has. What should we start this with? I'm going to go 5. So every 5 frames, so 25 frames a second, you're going to get 5 samples every second. We'll just see how we go. Minimum pixel area to count as motion. Oh, awesome. So that will get rid of the cursor problem. So if just the cursor's blinking, it will skip it. So that's awesome. So that's saying 500 pixels. Yeah, I think that's right. That sounds good. So what would that be maths-wise? It's 50 times 10. So that's kind of like the size of 2 fav icons in a browser, 500 pixels. A little bit bigger. Yeah, that'd certainly cover a cursor movement. We'll go with that. Diff threshold, grayscale diff threshold. No idea what that's going to do. So another thing is, like, I think the results I get for using this on like screen recordings like this versus actual video, like camera footage, would be completely different. So that's going to be another factor here. Later on, if I get into, running any of this over actual camera footage, there's even my webcam footage, I could do effects where, like, if I'm, gesticulating or whinging, it could zoom in and do stuff like that. Problem for later. Right. So job ID, what does it need? Needs, does it need an input file? Okay. It wants the input file, which means I need that, because I got the argument that the command already to run, and we're gonna go with this video. Oh, god damn it. Okay, that's in there. So, motion detection, job ID, 17 part 2, and that file. I'll probably pause again. I don't think this is going to be quick. Let's see how we go. Is it going to work? Wow. That was quick. Let's look in our workspace. I don't think it did anything. It's sort of stuffed it up. It hasn't followed. I don't think it's followed the, yeah, look. Okay, let's get Claude to fix this. Define a main method like has, so I can run this in isolation from the terminal. I could have probably just copied and pasted this. What's it doing? So input job ID config. Yeah, I think it would be a straight copy paste. There's nothing. Yeah, it's done that. Cool. All right, let's try it again. That certainly did something this time. Things are happening. Yep, motion. So it's created that motion directory. So it's doing something. Yeah, so this ran very, very quickly that first time. Then I'll let this run. The next time it runs. Oh, okay, no, it's finished. There we go. So we have loads of data. How to make sense of this? Okay, here's what I'm thinking. Because I think naively I thought I'll be able to look at this and go, oh yeah, okay, that's cool. I can judge from just the raw data, of which there's 195,000 lines, what they'll do. But clearly that's just not going to be intelligible for me. So here's what we're going to do. This will be cool. I want to see the data as I'm writing this prompt. Create me a standalone HTML file I can pass the motion data JSON file to and see a playback of each frame's detected region, drawing red boxes for each region and a timeline to evaluate the motion events over time. Now, really what I'm going to want to do is, I've said HTML file, like, let's just tweak this. Create me a standalone Python script to output an HTML file. I want to pass the motion data file to it and see a UI with playback of each frame's detected region, drawing red boxes for each region, a timeline to evaluate the motion data events over time. This is going to be like a test utility. So this is what I'll use to tune the data. Off you go, Claude. What I'm thinking is, we'll work with the data, and then as I work on a kind of smoothing algorithm, we'll get it to generate out the same data structure. So what I want to end up with is one region per frame, so to speak, and then we'll do frame culling, and essentially what I think is going to happen is this is going to create something and we're just going to get red blocks everywhere, and it's going to be completely useless. So we want to go from red blocks everywhere to kind of one block per frame, and then just try and keep tweaking this algorithm until you're sort of seeing, you know, smoother red boxes. Once we're at that point, then we can start work on actually throwing this to FFmpeg and going, okay, apply these panning and zooming operations. Because if we can't smooth this data through this kind of test UI, then there's no point doing the FFmpeg stuff. This is also going to be way quicker because having like a little web page to simulate this will be instant. It'll just run on the data as I tweak it each time, rather than render a goddamn video. Still no idea if this is going to work, but this is the quickest approach I can think to do it. Now, whatever Claude creates for this, it's not going to be. I can't imagine the playback would match the same speed as a video. Maybe it will. It doesn't really matter. I'm not about. I don't care about seeing something that matches the video one-to-one, but enough to give us an idea of like, okay, what are these red boxes doing? Just had a cool idea actually. If this works, I could actually get it to overlay on the video. So load the video on this little HTML page, either behind it or side by side, and then we could see the boxes with the video. Might do that if this works. So it's certainly having a thing. I thought that would be quite quick, but clearly I've stressed Claude out. I'll pause while it's still thinking. Okay, that took a while. I have a suspicion I may have just fed Claude this entire file. I think it may have read this, and I've just burnt the context window out and my usage session for the next hour or so, which I think is going to be maxed out fairly quickly, but that's cool. I think we are heading into two-parter territory for this video, but let's see if we can see the red boxes. I'll do a little bit more here, and then we'll do a part 2. So what's it spat out for me? Done. Here's what was created. New standalone script. It's updated the motion script, so let's rerun that immediately, and that can bake this data into the motion file here while we're still reading. Bounding boxes on gray placeholders, no video needed. So I run this and it's going to load this thing up. With actual video frames extracted, recommended. So what I was just talking about as an idea, Claude's just gone ahead and gone, hey, I know what you want. I'm going to do it anyway. I'm not going to run that first time. Custom output path and more embedded frames. What the HTML shows, stats bar, events count, peak motion times stamp, mean score frames per second. This peak motion concept is like, I don't know if that means, I mean, I guess it's like, where is the peak motion on the video? I'm not sure. Timeline, canvas chart of motion score over time, hover to preview time stamp, click to select a frame viewer. Not sure I'm going to get this. I'm not sure it's going to do what I want, but super excited. Let's run the damn thing. So we want, first let's copy all of this out. Don't need that prompt anymore. And we will go, it needs the job ID. Get that. Cool. So as we work on this, all I need to do is point it in the workspace where it's generated the job, and getting cocky. Can't open, because I'm in back end. Let's run it again. No video, rendering bounding boxes on placeholder canvas. Okay. It spat this out. Holy moly, what has this done? Wow. Well, there you go. Be careful what you prompt for. Where's my boxes? Yeah. See that? Crap. This is amazing. What am I thinking? So the way it's done this is because of that sampling effect. We're not seeing the boxes on every frame. So I'm going to go back and go change it to just show the frames where there's data. I don't understand, because it looks like there's still two sets of data, because it almost seems like there's data for every frame, and then there's the frames, as in there's a data point for every frame in the video, and then there's the data points, the samplings taken for where the red boxes are. So we get two changes, and then we'll call it quits. Two changes. One, if I don't specify the video argument, eliminate frames that weren't sampled. Add a play button that will automatically cycle through the frames at a rate of about 1 per second. Whisper didn't get second. Okay, we're on a branch. I'm going to commit all this because there's a chance it could cock this up. Motion detect 1. And we'll run that. So this is only for the this utility. So this script, I can't even remember. Where's it put it? Okay, it's under Okay, it's just laying there, visualize motion. So I'm asking it to change this with some controls in the HTML. So cool. Still thinking. We are close to session limit. Done. No video frames are null, no placeholder generation, no numpty dependency. The events list and timeline still shows. The frame viewer just shows a provide message for those events. Play button. Red play button in the viewer header. Okay, we need to generate this again. Doing that. While we take a look, just a question. Why was numpy removed? Ask before edits. And let's see what it generated, and then I'll come back for that prompt. Okay, here's what we got. Oh, there's the play. Okay, which is not working. That hasn't worked. I'm not seeing any frame data. Yeah, it's sort of cocked this up. All right, I need to understand what's happened here. Okay, it's stuffed up. I'm going to undo its changes. So this is the benefit of a good Git workflow, because obviously I'm not very across the code it's generated. I wouldn't be able to unpick this. I could tell it to undo it, but I don't need to. So I can just go discard, and we are back where we were. Now, session is almost maxed. I'm going to do a clear. It's probably not a good idea, because it's going to need Claude to reread the context for what we're doing. But given it just made a mistake, given how much context there was in the window for this chat so far, most of which would be valuable for it, I think it would get it in a twist. I've seen this happen with Claude, where if you get to this point where it's sort of not understanding what you want and you keep going, it can get in a twist. So I'm going to regenerate, make sure we can get back our red boxes. So play button's gone. Can't actually find any red boxes now, which is a bit worrying. Yep, there they are. And we'll try prompting this again to get what we want. So what I might do is just ask for a play button. In fact, why don't we run it with the video? No, we're going to need a play button. Okay. Okay, I've written a little prompt. This script displays video and motion data for sampled frames in a video. Add a play button that will cycle through each data point so I can see a playback of the data in the browser. See a playback of the data in the browser, and I'll say automate the. So this is where I like to kind of give it a bit of info. We open it up. Frame viewer. See a playback of the data in the frame viewer. So it should get, oh, okay, I think I know what it wants to do. In a video, add a play button to the UI that will cycle through each data point. Yeah. The way I've written this prompt is like, I've cleared Claude code out. It's gone Groundhog Day. It knows nothing about this script and what it just built, which is the whole point of clear. So it's starting fresh. So now it's reading this file, and only this file it should read, and then going, okay, I can make changes now. it's got the idea very, very quickly. So this to me, I may be wrong, please correct me. This is where I think the previous chat was overfitting context. I had so much context from building the extraction script, building this, me going on about, changing the script ordering and all that. We've kind of overbaked it. So doing a clear, you can tell it's got the idea. It's okay, I'll just do this task and I don't have to think about all the memory of the conversation. And I tried to give it a kind of clear instruction of what I want, and it's done. Regenerate. Let's see if it worked, or whether my approach is completely rubbish. Exactly what I wanted. Yeah. Okay, now, because we're partway there, I'm going to do one more thing, and then we'll close out, and then we're going to pick up in part 2. We'll commit that. Playback. Okay, let me just read what it says. Red circle button below the frame metadata. Speed. 10 positions. Frickin' awesome. Progress counter. Let me get my terminology right here. Can you make it skip frames where no data is embedded? So effectively, I've asked for the same thing I did before I discarded its changes. I've done it in 2 parts. So I've said, okay, let's first get the playback going, and now I want it to skip the empty frames during the playback, which it didn't do successfully the first time. Again, me doing bad prompting. I'm prompting based on not knowing the code very well. So I am kind of vibe coding rather than being a proper software engineer. Okay, reckons it's done it. Regenerate, refresh, and let's see what we've got. Yeah, look at that. So what can we do with this? What I want you to imagine as you're watching this, let me get my frame in view a bit. Oh, don't want to share my email. So all those little red boxes, very, very easy calculation to go, what is the absolute top, absolute left, absolute bottom, and right value of all those boxes together? Because that's really where all the movement is. So we're not interested in the individual boxes. We're interested in the space the overall boxes have. So first stage is going to be like, okay, take each frame and all the boxes and work that out. And so that'll be the first pass. So and I'll do this in the next video, we'll get that in the first pass, and then we're going to get a kind of bit of smoothing. And then what I mean by the smoothing is we don't want it jumping around too much. And if it's only moving a little bit, I don't want it to go, oh, zoom in, zoom out, zoom in, zoom out. We almost want to sample this data and go, okay, zoom to here, wait a bit, or like get a segment of data that we're thinking about zooming in on, look ahead in the data, find the maximum amount of zoom we need to do, go to that, rest, then do it again. So this is good kind of, it's more algorithmic work. It's less about the data structures. The data structure here is very, very easy. But how we process this and have some kind of windowing algorithm, as in a window of the data, this frame data, will then spit out something that I can then feed to FFmpeg to go, okay, take this and apply zooms and pans. And then we can tweak it. But the awesome thing about having this viewer is I can get 90% of the way there just based on having this. So we'll write algorithms that do this until this looks kind of smooth. and then it will be very, very simple to just wire up FFmpeg to do this. Now, having said that, as soon as I've got the kind of bounding algorithm working, we'll do the FFmpeg part, because there's no point working on this or this smoothing algorithms if FFmpeg can't zoom and pan in a nice way anyway, which would mean all of this gets abandoned. So next video, we'll do the bounding, and then we'll probably get FFmpeg processing the data. That's probably going to be enough for one video, and then maybe a part 3 we'll come back on the algo and improve the smoothing, and then we'll see if all this is going to work.